Shweta Gaurav, PhD in Physics from Delhi University. Now we will discuss photoelectric effect. Photoelectric effect. When a photon of frequency mu is incident on a metal plate, it will emit some electron. These are called photoelectrons. The emission of photoelectrons depends on few things. First, nature of material. Second, frequency of incident photons. And third, intensity of incident photons. There is a condition: when mu is greater than mu naught, then only the emission of photoelectrons is possible, where mu is the frequency of incident photon and mu naught, if we write in terms of energy, h mu naught is equal to work function of metal. It is different for all materials. Now we write the total energy incident is h mu. According to the law of conservation of energy, it will be equal to h mu naught, that is work function, and the rest amount of energy is kinetic energy. Due to this kinetic energy, the photoelectrons move in the system. In photoelectric experiment, we generate photoelectric current. Here are two plates, cathode and anode. Photons are incident on one plate, and electrons are emitted. This is a vacuum tube. To generate photoelectric current, we apply some potential. Here, this is called stopping potential. It will generate current. This stopping potential is applied to the loss of kinetic energy due to loss of kinetic energy due to stopping potential is q v naught. So we can rewrite the equation: h mu is equal to h mu naught plus q v naught. We write this equation in another form, like q v naught is equal to h mu minus h mu naught. This is simply a straight line equation. Y is equal to mx plus c. Here intercept is negative. Slope is, we can find slope from here. Q v naught is equal to h mu minus h mu naught. So the graph will be like that. So the graph will be like this. This is Ek or q v naught. I think we can write, this is slope and this is frequency mu. Here it is, this point is mu naught. If mu is greater than mu naught, emission is possible, and this is kinetic energy. And if mu is less than mu naught, here no emission of electrons. No emission of electrons. Now we will discuss some questions based on these concepts. In photoelectric effect, the work function of metal is 3.5 electron volt. The emitted electrons can be stopped by applying a potential of minus 1.2 volt. Here are four options. Option 1 says the energy of incident photon is 4.7 electron volt. Option 2, the energy of incident photon is 2.3 electron volt. Option 3 says if higher frequency of photon be used, the photoelectric current will rise. And the fourth option says when the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. So, as we know, h mu is equal to h mu naught plus q v naught. This is work function and this is stopping potential. So, from question, work function is 3.5 electron volt plus q. Q is the charge of particle. Here electrons are emitted, so charge of electron is minus E, and stopping potential is given in the question. It is minus 1.2 volt. So the energy of incident photon is 4.7 electron volt. Option 1 is correct. Option 2 is not correct. What option 3 says? It says if higher frequency photon be used, photoelectric current will rise. Photoelectric current depends on intensity, not frequency. And 4th option says when the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. This option is also wrong. So option 1 is correct. In this question, plot of stopping potential versus frequency mu is given here, and we have to find out threshold wavelength lambda naught. Now, we know that from the graph, this is mu naught, is the threshold frequency. So, mu naught is 5 into 10 to the power 14 Hertz. We all know C is equal to mu lambda. Here I am writing mu naught and lambda naught. Mu naught is threshold frequency and lambda naught is threshold wavelength. C is speed of light. It is 3 into 10 to the power 8 meter per second. Mu naught is given, 5 is 10 to the power 5 into 10 to the power 14 Hertz, and lambda naught. We get the solution. Lambda naught is equal to 6000 angstrom, where 1 angstrom is equal to 10 to the power minus 10 meter. So option B is correct. The question says, which one of the following graphs represents the variation of maximum kinetic energy of the emitted electrons with frequency mu in the photoelectric effect? There are 4 graphs here. As we know, the equation is h mu is equal to h mu naught plus Ek. Here we write this equation in this form, h mu minus h mu naught. This is a straight line equation and it satisfies option D. Here the intercept is negative. Intercept is negative and this is slope. So option D is correct. Hope you like the video.